Hello, students. Today, we are going to study the elemental composition, component analysis, and colloidal structure of petroleum bitumen. During the construction of an asphalt pavement on a certain highway, the quality of the asphalt is unstable, resulting in significant differences in high temperature stability and low temperature crack resistance among each batch of asphalt mixtures. Please analyze the reasons for this. With this question in mind, let's begin today's study. This micro-lecture is divided into three main parts: the elemental composition of bitumen, the component analysis of bitumen, and the colloidal structure of bitumen. 1. Elemental composition of bitumen. Bitumen is a mixture composed of various hydrocarbons and their nonmetallic derivatives. Its main components are carbon, 80% to 87%, and hydrogen, 10% to 15%, followed by other nonmetallic elements such as oxygen, sulfur, nitrogen, etc., with a content of less than 3%. In addition, there are trace amounts of metallic elements. 2. Component analysis of bitumen. Petroleum bitumen is a mixture composed of various compounds, and current analysis techniques make it difficult to separate bitumen into pure compound monomers. In order to study the relationship between the chemical composition and performance of petroleum bitumen, components with similar chemical properties in the hydrocarbon compounds contained in bitumen are often classified and analyzed, thus divided into several groups, referred to as bitumen chemical components or simply components. The chemical analysis method that divides bitumen into different compounds is called component analysis. Bitumen component analysis utilizes properties such as selective dissolution in different organic solvents or selective adsorption on different adsorbents. China's current standard JTG/E20-2011 test code for highway engineering asphalt and asphalt mixture specifies two methods for component analysis: 3-component and 4-component analysis. The 3-component analysis method separates petroleum bitumen into oil, resin, and asphaltene components. This analysis method combines selective dissolution and selective adsorption, so it is also called the dissolution adsorption method. The advantages of the dissolution adsorption method are clear component boundaries, and, to some extent, the component content can indicate its road performance. However, the disadvantage is that the analysis process is complex and time-consuming. The 4-component analysis method separates petroleum bitumen into asphaltene, saturates, naphthalene aromatics, and polar aromatics. The 4-component analysis method analyzes petroleum bitumen based on its composition, which is its superiority over the 3-component analysis method. Let's return to the introductory example during the construction of an asphalt pavement on a certain highway. The quality of the asphalt is unstable, resulting in significant differences in high temperature stability and low temperature crack resistance among each batch of asphalt mixtures. Please analyze the reasons for this. The on-site laboratory conducted 4-component analysis of the asphalt and found that the components of each batch of asphalt were significantly different. The manufacturers ultimately controlled the quality by adjusting the component ratios. In daily life, what characteristics do you think wax has? In the chemical composition of bitumen, the wax content is a crucial part. The influence of wax components on bitumen performance is an important topic in bitumen research. Especially in China, The abundance of paraffin-based crude oil has attracted significant attention. The impact of wax on asphalt road performance manifests as follows. It makes asphalt soft at high temperatures, leading to a decrease in the high-temperature stability of asphalt pavements and the formation of ruts. Similarly, at low temperatures, wax reduces the adhesion between asphalt and aggregates, leading to a decrease in the low-temperature crack resistance of asphalt pavements and the occurrence of cracks. Introduction. Can oil stains on clothes be washed away with water in daily life? What must be used to clean clothes? Yes, detergent such as laundry powder must be used to clean clothes. What is the principle behind this? With such questions in mind, let's start the third part of today's content, the colloidal structure of bitumen. According to colloid theory, bitumen consists of asphaltene as the dispersed phase, saturates and aromatics as the dispersing medium, and colloids act as the solvent. Several asphaltene aggregates come together to form a gel nucleus. Colloid fractions are adsorbed on their surface and gradually diffuse outward to form colloidal particles, which are then dispersed in the liquid aromatics and saturates, forming a stable colloidal structure. Based on the different chemical compositions and relative contents of various components in bitumen, 3 different colloidal structures can be formed: sol structure, sol-gel structure, and gel structure. The sol structure has a low asphaltene content in bitumen with a higher content of oil and resin. Asphaltene can move freely in the colloidal structure. The most representative example of the sol structure is straight-run asphalt, which exhibits low viscosity, high fluidity, good plasticity, but poor temperature stability in its road performance. The gel structure has less oil and resin content, but higher asphaltene content. The mutual attractive force between colloidal particles increases, making mutual movement more difficult. This type of asphalt has higher elasticity and viscosity, hence called elastic asphalt. Oxidized asphalt belongs to this type of asphalt. The road performance of this asphalt is characterized by low temperature sensitivity, lower fluidity, and plasticity. The sol-gel structure has a lower asphaltene content than the gel structure, but contains a suitable amount of oil and resin. Therefore, it is also called viscoelastic asphalt. Most high-quality road asphalt belongs to the sol-gel type structure. The composition and classification of bitumen are complex, and its technical properties depend on its chemical composition, chemical structure, and colloidal structure. Students should consolidate their knowledge seriously after class and lay a solid foundation. Thank you for listening attentively to this micro lesson. Goodbye and see you again.